of, so we can find the mean. Okay, so this is what we say when we say that some random variables are discrete. It can only be plotted on a number line in dots. You don't connect them. You plot them in dots like this. You cannot connect them because they are discrete. Discrete random variables. You just plot them as dots. Okay. And when it is continuous, you can connect them. So you see in this one, you connected the numbers because you connect them. Why? Because it's continuous. If it's not connected, if the dots are just plotted, it is hello? Yeah, now I'm in class. But give up. Just go ahead. Go ahead.
Okay.
Oh, yeah, they just left. Okay. I'll call you back, okay? Okay. Okay. All right, so distinguishing between discrete and continuous. So we are trying to distinguish. The first one is how to plot the points. If it is discrete, you plot dotted line, dots, then connect them. If it is continuous, because it will contain decimal, then you can can connect them. So I showed you the two lines. The first one is discrete, only dots. Second one is continuous, connected. All right, so now we have a table here. And in this table here, we are going to be told to find, first of all, decide, is this a discrete probability distribution? Yes, like well, let's check by the properties of probability. The first thing we want to do is to add all the probabilities. If the probabilities are equal to 1, then it is a discrete probability distribution. But if it is not equal to 1, then it is not. So let's go ahead and add them. So we're going to add them. I'm going to pull my calculator up so we can do the addition of all the probabilities. We add all the probabilities and see if they are equal to 1. All right, so that's what I'm going to do now. Get my calculator, put them in. So the first one is 0.06 plus 0.58 plus 0.22 plus 0.1 plus 0.03 plus 0.01. Okay, so this is what I'm told to add. And then if I hit enter, so the sum of all the probabilities is equal to 1. Therefore, this table is a table of discrete probability distribution. And since it is, I'll go ahead and find the mean. The mean, and I can find the mean without calculator. So I can find the mean without calculator. All right, so if I want to find the mean, all I have to do is multiply. I'm going to find another column. So this is the expected value. So probability multiplied by the discrete. So I have to 0 multiply this is 0.0. So there will be 0 from here. Plus 1.8, 1.58. What I'm doing is multiplying them. 2 times 0.22 is 0.44. 3 times 0.1 is 0.3. 4 times 0.03 is 0.12. 5 times 0.01 is 0.05. So when I add the sum of all the x, random variable multiplied by the probability, what I have is the expected value. So the expected value is the mean. So the mean of the distribution is equal to the expected value or expectation. It's called expectation. Expected value. And that is equal to my answer. So I'm going to get the expected value now. I'm going to get a calculator, add them up, add the multiplication of each random variable to its probability. I add them up. So that is what I'm going to do right now. So 0 multiply 0.06 is 0 plus. The next one is 1. The next one is 0.58. So 0.58. So this is going to be plus 0.58. I'm going to clear that. Okay, so 0 plus 0.58 plus 0.44 plus 0.3 plus 0.12 plus 0.01, and then the mean or the expected value of this distribution is 1.45 by hand. So we can do it by calculator. We can also do it by calculator. It's important you know how to do it both ways. It's important that you know how to do it by hand and by calculator. So I'm going to pull my calculator up now, go to start and edit. And I'm going to clear everything I have in L1, every list. I don't want anything in the list. Okay. And then clear L3 and clear L2. Also clear L1. All right, now I will put in all the random variables. Random variables are X. Random variable, they are random. So X, when X is 0, enter 1, enter 2, enter 3, enter 4, enter, and 5, enter. I want to make sure that I change the mode to float. So I'm going to go to mode and change it to float because this is probability. So I don't want to put it to 3 decimal places. Okay, now the next thing I want to do is go back to stat, and I am going to put in the L2, the probabilities. So 0.06, enter, 0.58, enter, 0.22, enter, 0.1, enter, 0.03, enter, 0.01, enter. Okay, so you see that they're on the same horizontal level. So I'm about to do one variable start. That's all. The same thing we found how to do in unit 1. So go to stat, arrow to calc, one variable start of L1. Do I have a frequency? Yes, but because this is a group data, so L2. So I have a frequency. The frequency, remember that probability is the same as relative frequency. So I have L1 and L2, and I'm going to calculate the one variable start. When I finish calculating, arrow down. And by the way, the mean, see, is more accurate here. The mean is 1.49. The more calculator is more accurate. The mean is 1.59. You'll be told to find the standard deviation. The standard deviation is to 3 decimal places, 0.933. So you can be told to find the mean, find the standard deviation. You can be told to calculate whatever you're told to calculate, but it is still one variable stat. But this time it's one variable stat of a group data. It's one variable start of a group data. So we have answered the question. We have, first of all, answered the question, is it a probability distribution? We say yes, because there's no negative probability to base the rule. The sum of all the probabilities is 1. Now the next thing we are told to do is find They haven't told us, but they will tell us to find the standard deviation and find the mean. The mean is called the expectation. So these are the rules that we talked about, the probability rules we studied. So probability rules we studied in Unit 2 also applies in Unit 3. It will also apply in Unit 4. So this is the third unit. This is Unit 3. Okay. Is the following a probability distribution? The same thing. If it's a probability distribution, the sum of all the probabilities must be 1. But you can see now they added it, the sum of all the probabilities is not 1. Therefore, this one is not a probability distribution. And if it's not a probability distribution, you do not need to go and calculate the mean. You do not need to go and calculate the standard deviation because it hasn't obeyed the rule. So you cannot continue. The only time you continue is the sum of all the probabilities is 1. In other words, when it obeys the rule of probability. Is the following probability distribution? Let's look. No, it is not, because there is a negative probability. It is not a probability distribution because it disobeys one of the rules of probability. It is not a probability distribution because in probability, you're not allowed to have a negative probability. It is not a probability distribution. So is this one a probability distribution? You add all the probabilities, and this one is equal to 1, and all the probabilities are between 0 and 1. So it's a probability distribution. I'm showing you examples so that then compute and interpret the mean. So the same thing, you compute, put this one in L1 and L2, compute and interpret the mean. And let's do that again. One last example of computing and interpreting the mean, so we can go to binomial. All right, so I will go to my start again, edit, and I will go to L1, and I have 0, 1, 2, 3, 4, 5. So this is still good. L2, I am going to clear L2, clear enter. And then I'm going to put in the probabilities in L2. So 0.16, 0.18, 0.22, 0.1, 0.3, 0.04. Okay. Okay, and then the next one is do one variable stat. So go to stat, arrow to calc, and do one variable stat. And then arrow down, calculate. All right, so I have calculated the mean, the expectation, and the expectation is 2.32. Remember that the mean is not the probability. So the mean of this is discrete random variable can be more than 1. Okay, and the standard deviation is 1.5. And if I'm told to find the variance, I will square the standard deviation and get the variance. So we already know this. And then, and that's all. You can really need to know how to do it by calculator and by hand. You need to know how to find the expectation by hand and by calculator. Okay, and the next thing is this is another example, but we have done enough examples. We have done enough examples. So the next thing is go to 6 point. You can do this using your calculator by using, okay, right, this one here. Okay. The next thing is go to 6.2. So this is 6.1, discrete probability distribution. So the next thing is 6.2, binomial probability distribution. Okay. So binomial probability distribution is the one that we're going to now. 6.2. So we're doing 2 sections today. Okay, the learning objectives for 6.2, 6.2, 6.2, and this is binomial distribution. 6.2, and this is called binomial distribution. We are only doing 6.1 and 6.2 in this chapter 6. Determine whether a probability experiment is binomial. So there are properties of binomial distribution. A binomial distribution must be a probability. So it's actually called a binomial probability distribution. Then compute probabilities of binomial experiment. Compute the mean and standard deviation of a binomial random variable. So compute the mean and standard deviation. And so what we do is go to criteria for binomial probability. In other words, the properties. What are the properties of, let me write it properties. So you know these criteria. So properties of binomial distribution. An experiment is said to be binomial experiment. One, the experiment is performed a fixed number of times. In other words, sample size must be given. All right, sample size must be given to you. That's what it means, a fixed number of times. Each repetition of the experiment is a trial. If you are throwing a dice, it's a trial. If you're flipping a coin, it's a trial. In other words, it's a probability. It's a chance. Probability is a chance. It's a trial. Each repetition of the experiment is called a trial. Okay, number 2, the trials are independent. In other words, if I flip a coin and a head comes out, it doesn't really mean that if I flip it again, a head will come out. So they are independent. The trials are independent. It's either a head or a tail comes out. They are equally likely. That's why we say they are independent. This means the outcome of one trial will not affect the outcome of another. Okay, that is one of the properties of probability. Okay, property number 3, for each trial, for each experiment, there are 2 mutually exclusive events. In other words, head or tail, and that's it. It could be, it is mutually exclusive, therefore it is disjoint. They cannot happen at the same time. What am I saying? If I flip a coin, only a head can come out or a tail. There's no way I can get a head or a tail unless it is a biased coin. If it's a biased coin, by the way, we're not talking about biases here. In probability, everything must be unbiased, should not be biased. Fair, we say fair coin. Fair coin means an unbiased coin. Unbiased coin means I am not allowed to have head and tail at the same time. Okay, success or failure. So that's what it means. Success or failure. True or false. Success does not necessarily mean that it is a good thing, just what they are talking about. Okay, success is what somebody is studying. It doesn't have to be what you like. Number 4, the probability of success is fixed. Okay, so it will be given to you. For example, you can be given that the probability of success is 0.3. So that is the probability of success. It is fixed. It cannot change in any particular probability. This follows from the fact that trials are independent. So since trials are independent, success is free, it cannot be changing from one outcome to the other in one experiment. Okay, so we're working on binomial distribution. We're talking about the properties of binomial distribution right now. So the notation used in binomial probability distribution, n is independent, n is the sample size. Sample size in binomial is the number of outcomes, number of trials. If I throw a coin 10 times, then 10 is the number of trials. The sample size must be given to me. If the probability of success is 0.5, then success is 0.5. You cannot change in that particular situation. If P denotes the probability of success, then Q is equal to 1 minus P. In other words, there are two outcomes. Success, P is success, and Q is failure. Q is failure. In probability distribution, success plus failure must be equal to 1 because of the property of probability. Success plus failure must be equal to 1. In other words, if I'm looking for failure and I'm given a success, 1, suppose I'm given that success is 0.3, and then I'll subtract 0.3 from 1, I will get failures. So if the probability of scoring an A in a test is 0.3, 30%, then the probability of not scoring an A is 1 minus 0.3, which is 0.7. So the probability of not scoring an A is 0.7. All right. Okay, so we're going to do an example. Which of the following are binomial? So we need to know the properties of binomial. 1, it has to have two outcomes that are independent, success or failure, true or false. The sample size is fixed and it must be given. Excuse me. Sample size is fixed and must be given. Success is fixed and success plus failure must be equal to 1. Okay. A player rolls a fair die, fair because it is not unbiased. Whenever we hear fair die, a die, by the way, is a 6-sided die. It has to be 6-sided. If it is more than 6 sides, it's not a fair die. The number of 7s rolled, by the way, it is a 6-sided die. So there is no 7 there. The number of 7 recorded has to be 0, impossibility. The probability of a 7 coming out is 0 because in a fair die, there is no 7 there. There's no face, that's a 7. Binomial experiments, the sample size is 10. Success is rolling a 7. Either get a 7 or not. That is binomial. Get a 7 or not. There is no 7. Therefore, that is called an impossibility. The probability of something not happening at all, no chance of happening, is called an impossibility, an empty set. B, 11 large airlines had an on-time percentage of 84.7 in November. According to Air Travel Consumer Report, in order to assess reasons for delay, see, the airport has 84.7% of success. It means that some planes did not take off. And what is the percentage? A whopping almost 15% of planes did not take off. All right, in that airport, an official with the FFA randomly selected flights until she finds 10 that were not on time. The number of flights X that need to be selected is recorded. In a class of 30, that's an example of, so you see, not a binomial experiment, there is no fixed number. So they did not tell us the number of times. They just told us, give us the probability. So because they did not give us the sample size is not given here. Sample size is not given. Therefore, it's not binomial. So we are looking for how to identify binomial distribution. If the sample size is not given, it's not a binomial. Okay, so it's not a binomial distribution because sample size is not given. C, in a class of 30 students, 55% are females. You see, sample size is given here. Okay, and we are given the probability of success. The instructor randomly selected 4. The number X of females selected is recorded. Okay, that is not a probability experiment. The trials are not independent because she wouldn't replace the first female that she selected. Okay, so the number of X of males selected is recorded. So the reason why they said it's not a probability distribution is that the number X of females selected is recorded. Okay, not a probability distribution. Let's go to another one that is, where it is clear that sample size is given and success is given. Okay, according to Air Travel Consumer Report, the 11 largest air carriers had, so this we are given 11. Given the success, suppose that 4 flights are randomly selected in May and the number of X flights is recorded. So success is 19% and a failure is this. Construct a probability distribution for the random variables. So we can actually, the first one, you can do a tree diagram. So success 0.919 and failure 0.21. That's for the first flight. And if there's another one, that's 2 chances again, and so on. And so that's how you draw a tree diagram, because they might ask you to draw a tree diagram. They might ask you to draw a tree diagram. Okay. I'm going to look for this one, compute a probability of X equal to 3. So X, which means the number of times it was done is 3 times. Number of times it was done is 3 times. Okay, so let's keep on going. And we have a distribution. So we can be given a distribution of binomial distribution. And in this one, we want to find, now you can see how much work goes into computing the probabilities that are in this distribution. Okay, and then given this table, you can be told to find the mean, find the standard deviation. But by the way, before we continue, we want to say that it's a formula for binomial distribution. Formula for binomial distribution. And the formula is n combination r. Remember, combination, order is not important. Okay, success to power r and failure to power n minus r. Okay, remember, we already know that this is n combination r. Sample size, combination the number you want at a time. Success will be given to you to power number you want at a time. Failure is 1 minus success to power n minus sample size minus number you want at a time. Okay, so this is this formula. You must know the formula offhand, by the way. And then you should be able to also use calculator to do the calculation. I will soon show you how to use calculator to do the calculation. Okay, so that is binomial formula. You can use this formula to calculate binomial probabilities, but it is easier to use your calculator. So I'm going to show you how to use calculator also. Whenever you are using binomial PDF, be careful. If you're using binomial PDF, it means you're looking for a single probability. Let me make sure I write it. Equal sign or exactly probability in binomial is PDF. You use PDF for this, binomial PDF. Binomial PDF equal sign. If any question says equal sign, it is binomial PDF. Okay, there's one called binomial CDF. You are accumulating. It means the probability is less than or equal to, you're accumulating to the left. If you are accumulating to, I'm going to draw a diagram. Anytime you are using binomial CDF, it means you are accumulating to the left. You are looking for sum of the area under the normal curve. Maybe I call it a normal curve, but you are accumulating. So, and in this case, you are using binomial CDF. So binomial CDF, cumulative density function. Cumulative density function is for cumulating from somewhere inside the normal curve to the negative infinity. All right. Okay. So we are going to continue. I'll do an example quickly so that you understand. It will be clearer when you understand. So whenever in binomial distribution, whenever you have a question with greater than or equal to, it means at least 1 minus binomial CDF. When it is only greater than, it's still you're still going to do 1 minus binomial CDF. If it is less than, then you do binomial CDF only. Binomial CDF only, no 1 minus. If you are doing less than or equal to, you still do binomial CDF. And binomial CDF means cumulate to the left. Equal sign is binomial PDF. Exactly, we already said that. PDF, binomial PDF is equal sign. Whenever you see equal sign, it means binomial PDF. Okay, example, using the binomial probability density function. According to the experiment, automotive, 35% of all car owning households have 3 or more cars. In a random example of 20 car owning households, what is the probability that exactly 5 have 3 or more cars? All right. What is the probability that exactly 5 has 3 or more cars? Okay, so 3 or more means the probability of X is greater than 3. That's what it means. And greater than or equal to is area to the right. Okay, so we use binomial. This is a precisely problem where P is equal to 5. What is the probability that exactly, oh, this says exactly 5. This one just says exactly 5. So we're going to take it away because it says exactly 5. And if it's exactly 5, it's a PDF. So let's find out what we are given. Random variable is 5. We are given sample size of 20. We're looking for the probability of success, and the probability of success is 35% of 0.35. So we can actually plug this into the formula. Plug into the formula. So we have n combination r, success to power r, failure to power n minus r. All right, so you have to plug in everything you have, and this is binomial PDF. So now I am going to plug it in, plug everything I have in, and then, All right, so I am plugging in this formula. Okay, I just move it up a little bit. Okay, so I know N combination R. So 20 combination 5. Success. Success is 35% of 0.35 to power 5. Failure. And failure is given to us. If success is 35, failure is so 1 minus 0.35 is equal to 0.65. So 0.65. And then the success is the number of a random variable is 5. Sample size is 20. Therefore, 20 minus random variable. Okay, so now we have to simplify. So you put this in your calculator. I'm going to show you 2 ways of doing this so that you know you can do it. I'm going to show you 2 ways. I am going to evaluate the formula, what is in the formula. And then when I finish evaluating it, I also do it with binomial PDF. Okay, so 20 combination. Remember how to get combination. Go to math, arrow to PRB. Combination is number 3. So combination 5. And then I'm going to multiply, multiplied. So I can just say multiplied by 0.35 to power 5, caret 5. Also multiplied by 0.65, which is failure, all to power 20 minus 5 is 15. All right, so I'm going to enter. So I get an answer. So that is the probability. The probability of choosing only 5 out of 20 is 1.127. Remember, it cannot be more than 1. It cannot be more than 1. And your answer cannot be negative because this is probability. Binomial probability distribution is also probability. It obeys the probability rules. Answer cannot be negative and it cannot be more than 1. Okay, so I'm going to redo this using binomial PDF. So I'm going to go to math. Actually, I'm going to watch how I'm doing this. Second distribution. I'll go to look for binomial. So I'm looking for binomial up. A is binomial PDF. Why? This question is an exactly question. It's an exactly question, and the number of times is 20. Success is 0.35. And the value of x is 5. And now I am going to paste. Okay, see, I did it by hand. I got the same answer with calculator. You can do it any way you know how, but the calculator is easier for you. You should know how to use it with both calculator and by hand. Should be able to do it by both calculator and by hand. So we calculated the probability that in a random variable of 20 with probability of success of 0.35, the probability of choosing 5 out of 20 is 0.127. In other words, 127 out of 1,000. 127 out of 1,000 number of successes. Okay, so we are still going down. So we can be asked to find the probability of an exactly event. All right. In a random sample of 20 cars, what is the probability that less than? So this one is less than. And less than means cumulative. So we are told to find the probability of around x is less than 4 this time. By the way, what are we supposed to do? It actually means we are told to calculate. Let me draw a normal curve. So less than 4. Remember, there are 20 of them. Let's say there are 20 of them, and we are told to calculate from 4 down. In other words, from 4 to 3 to 2 to 0. This is 4, and 3 somewhere, 2 somewhere, 1. And this is just a diagram. This is and by the way, all of them are 20. So 20 is going to be somewhere here. Anyway, how do you write it? Binomial cumulative density function. Why am I using cumulative this time? Because it is less than 4. So I'm cumulating from 4. And by the way, it's less than 4. So actually, 4 is not included. 4 is not included because it's only less than 4. 4 is not included, so you got to be careful. And the argument is NP R or NPX, sample size, success, and the number at a time. But this is less than 4, so we're going to just write x minus 1 because they told us it's less than 4. Okay, so I'm going to now substitute what I'm given. So the sample size is 20, success is 0.35, less than 4 means starting at 3. So let me calculate. So calculate, and I'll get one answer. Then I'll show you another way of doing this thing again. So I'm going to go to second distribution and arrow to probability. This time is, binomial probability distribution, binomial CDF. And the number of trials is still 20. The success is has to be constant, 35%. The value starts from 3, not 4. Why? Because it is less than. And so I'm going to, so the probability of doing less than 4 is 4.44%. Or 0.0. You see, you can leave your answer in decimal or percent. So this is the cumulative probability or less. So you accumulate into the left. When you accumulate into the left, you just use binomial CDF. And by the way, what does this mean? It means P0 plus P1 plus P2 plus P3. P4 is not included. And what does it mean actually? What does it mean? Let me make sure we understand what this means. P0 means 20 combination 0, success to power 0, success to power 0. Let me put 0.05 here, 0.0535 to power 0. And failure, what is failure? 0.65 to power 20 minus 0. 20 minus 0 is 20. So this is P0. I just want to make sure you understand what it is. Okay, then I am going to calculate this and I will add it plus P1. And what is P1? P1 is 20 combination 1 multiplied by 0.35 to power 1 multiplied by 0.65 to power 20 minus 1, which is 19. And then I add it. So I get my answer and I add it. Then I find P2. And what is P2? 20 combination 2, success to power 2, and failure to power 20 minus 2. So you just have to make sure you understand that P1, P2, P3. Hello? I don't know. I don't know class because I have to, I'll call you back. Okay. All right. Yeah, I'm sorry. I have an emergency, family emergency, so that's why I'm picking up the phone. I hope you understand. Okay, so now if I'm told to find P3, 20 combination 3, So if you're told to find them individually and make a table, this is what you have to do. 0.35 to power 3 times 0.65 to power 17. That's 20 minus 3. Okay. And when you finish, you make a table. We have already